Hi, this is Sung and I'm your online maths mentor, and today we're going to be looking at a brand new topic. The topic that we're going to be looking at is polynomials. So polynomials is the topic, and let me just say you will have already dealt with polynomials before. So what I'm going to talk about is some of it's not really new to you, all right, but some of it will be. Okay, so it's an exciting topic. It has a lot of applications when it comes to the Extension 1 course, as well as the 2-unit course, the 2-unit mathematics course. So let's just launch straight into it. So what is a polynomial? Okay, a polynomial is basically an expression that has terms with x in it, and it's x to a power. So it has terms of x, various x's to different powers. Okay, so you might start off with x to the power of a number, say n, with a constant at the front. Okay, we'd call that constant an. All right, now that constant out the front is called a coefficient, or a number out the front, which is called a coefficient. Okay, and that is basically the general form of a polynomial. It's a number or a coefficient out the front of an x term to a power of n, all right, and then plus or minus another x term, this time to a lesser power. Okay, x to the power of one number less. All right, so x to the power of n minus 1, again with a constant term out the front, or a coefficient out the front, which will be different to the one that was before it. Okay, and it just keeps going in descending order all the way until you get a term on the end. Okay, or a constant on the end. All right, so a polynomial can be represented by the expression p outside of x, or p of x. All right, p for polynomial, and it's a polynomial to the variable of x. Okay, so that's the way it works. Terms, right? Terms, each part of the polynomial is called a term. So that's a term. It has a coefficient, it has an x or a variable, and it has a power. All right, so that's called a term. So in this particular polynomial expression, there are, well, you start here 1, 2, 3, 4, all the way up to n. So there's n plus 1 terms, because the constant is also a term as well. All right, so n plus 1 terms, and a polynomial is basically the sum of a series of terms in where the power is in descending order. Okay, and each x term has a coefficient out the front. All right, the leading term is the one with the highest power. Okay, so if the leading term had the highest power of, say, 5, all right, and a coefficient of 4, it would be 4x to the power of 5. Does that make sense? So, and then the degree of the polynomial is the highest power that it has. So if the highest power was 5, then it would have a degree of 5. Does that make sense? All right. Coefficient is the number in front of the x term. All right, and the constant is the non-x term on the end. Okay, the constant is the non-x term on the end. So let me have a look. Let's have a look at an example together, or let us have a look at an example together. So just say you had, let's say, 4x to the power of 5 plus 3x to the power of 4 plus 7x to the power of 3 plus 12x squared plus 5x plus 1. All right, so let's have a look. So the polynomial here would be p to the x. In this particular polynomial, how many terms are there? There's 1, 2, 3, 4, 5, 6. There's 6 terms in this polynomial. This would be one term, this would be another term, this would be a third, fourth, fifth, and sixth term. Does that make sense? So if it goes to the power of 5, there will be up to 6 terms in the polynomial. Does that make sense? All right, the leading term will be the one with the highest power, which is the 4x to the power of 5. That will be the leading term. The degree of the polynomial would be 5 because that's the highest power. Okay? So 5 would be the degree of the polynomial. The coefficients will be 4, 3, 7, 12, 5, and 1. They're the numbers in front. Okay? Now, when it comes to extension 1 work, usually what you will find is the coefficients of the polynomials will be integers, all right? Either positive or negative, all right? It is possible to have non-integer coefficients, and sometimes in extension 1 you will deal with non-integer coefficients. It is also possible to have irrational coefficients, all right? And when you deal with if some of you are doing extension 2, you will also find that it is possible to have complex coefficients, okay? So you can have the coefficients in any number system, all right? However, the powers, the degrees or the powers will be coefficients, okay? So 5, 4, 3, you can't really have these powers being anything other than integers, okay? All right, and constant term would be 1, all right? Does that make sense? Because it's the constant term is the non-x term, yeah? Good. Now, remember how I said before that you will have seen polynomials before? Where have you seen them? What are some polynomials that we have dealt extensively with in the mathematics course or also in the extension 1 course? Well, we've dealt with, what's this? Well, these are obviously quadratics, yes? So quadratics are a form of a polynomial where the highest power is 2, yes? And the leading term, let me say something about the leading term. The leading term cannot be 0, okay? It has to be a non-zero integer, all right, or a number, okay? And where it is, say 1, then you say that the polynomial is monic, and I'll write that up there. It's a monic polynomial if the coefficient of the leading term is 1. So if the coefficient of the leading term is 1, then we say that it's a monic polynomial. So if that term there was a 1, it would be monic. Okay? So your quadratics are a form of a polynomial that you will have seen before, and also linear. Linear equations are also a form of a polynomial, aren't they? Okay? Good. So I just wanted to go through that as an introduction for you. And then in the next episode, what we will do is launch straight into polynomials. We'll look at how they look or appear in a graph-like form, and we'll also look at how to divide polynomials, okay? So thank you very much for watching, and I'll see you on the next episode. Thanks.